Good afternoon, everybody. It's 5 o'clock on Tuesday, which means it's time for math. My name is Jeremy Jasper with KathleenJasper.com. And for the next hour, we're going to do all things math for your certification exams. So welcome in on another Tuesday session. For those of you that join me regularly, welcome back. Thank you for joining me. And for those of you that are new, again, this is an informal math session where we go through 10 problems that are associated with generally any type of math certification exam that you'll be taking. And it's just here to help you get a better grasp on things, learn a couple concepts, a couple shortcuts, tips, tricks, anything of that sort. So we're live on our Facebook page and we're also live on our YouTube channel. If you don't watch us live, that's okay, because after the live session from 5 to 6 p.m. Eastern, we go ahead and upload it, and then it's available to you on demand. The problems are in the link below. So whether you're on Facebook or YouTube, you'll see the link right there. You can download the problems. They will come on one page per problem. And that's because I give you the opportunity to do all your work on that blank space. Because remember, when you're practicing, when you're taking the test, all you have to work with is a scratch sheet of paper or kind of like a dry erase board at the test center. You are not able to work on the screen. You're not able to work on paper or anything like that. So you have to get used to using scratch paper. And then second, make sure you have your calculator. Make sure you have the correct calculator for your test, because that's important. You get to the testing center and you're so used to using your phone as your calculator. Well, now you're going to be a little bit screwed up because you're not used to using anything other than your phone. All right. During the session, if you have any questions or comments, please feel free to put them in the comment section, whether you're on Facebook or on YouTube. I'm going to go ahead and open that up now so that I can make sure and see any comments. Okay, for the YouTube, because there's a question on here. If you're just Google search, or not Google search, but go to YouTube and it's just Kathleen Jasper and you'll see it pop up, and it's a live video right now. So you'll be able to go ahead and do that on YouTube. Looks like we got some people on the Facebook. Let me double check, make sure we're on YouTube, and then we're going to get this thing started. So just give me 1 second as I go ahead and take care of this. And I'm going to go. Sorry about the dead air. Okay, so there we go. We're good to go. I'm going to put the problems up and away we go. All right, so you see here's the first problem. Now, there's going to be assortment of word problems. There's going to be geometry, algebra. There's a little bit of everything in here. So no matter which test you're taking, the skills that I'm going to show you are always going to work for you. Just doing basic mathematics is going to help you on your math test, okay? And then just as I go through and I show you different ways of doing using the answer choices to figure out the problems, there's a multitude of ways that we can go about doing it. I just kind of throw everything at you. I'll never tell you to do it one specific way. I'd rather you choose the one that's most comfortable for you, because if I teach you something today and you're taking the test tomorrow and it's the first time you learned it, chances are you're not going to remember it fully, because once you're in that test situation, the test anxiety, everything that stresses you out takes over and you go into primal mode, and you just, whatever your brain knows and is in concrete is what it's going to go with. All right, so we got this problem here. It says Mr. Johnson purchased 20 concert tickets for a total of $225. The concert tickets cost $15 for adults and $10 for children under 12. How many tickets for children under 12 did Mr. Johnson purchase? So the first thing I go to is that this is a systems of equation problem, which means there are two equations that you can make for this problem because there are two different variables. We have adult tickets and we have child tickets or children or kid tickets. So we'll use A and C for that. Well, whenever you have two variables, you need two equations to solve, right? One variable, only need one equation to solve. Two variables, you need two equations to solve. Three variables, three equations, and so on and so on and so on. So we want to go ahead and create our equations. So I've got adult tickets. It says we purchased 20 concert tickets for a total of $225. So we know that we have adult tickets plus our children tickets is going to equal 20, right? That means if you take the amount of adult tickets you bought and the amount of children tickets or child tickets, I don't know why I'm getting so screwed up with that. It just doesn't sound right, but whatever. So adults and children, there are 20 of them. Then associate each variable with the cost, because now it gives you the cost of $225, right? So I know that adult tickets are $15. So it's $15 for every adult ticket. It's $10 for every child's ticket. And the total cost was $225. So now in the question, it says how many tickets for children. So we need to focus on children. That means that we have to isolate only the variable associated with children, which is C. So how do I do that? We'll take, let's clean some stuff up. I know that I'm going between these two, there's two things that we can do with systems of equations: elimination and substitution. Elimination is if I stack these two on top of each other like they are, can I have the same of each variable? So see, I have A at the top and 15A at the bottom. They're not the same. One has 15, one has A. I can't cancel them out. I can't eliminate them. And when I say eliminate them, I mean subtract them or add them, because if one's negative, one's positive, and so just know that we're not going to use elimination. We're going to use substitution, which means I'm going to manipulate this equation here because each of these are single variables. Single variables are easy to work with because what you want to do is isolate it and then use it to substitute into the other equation. So the way I want to isolate this is I'm looking to solve for C, which means I want this equation where I isolate A, and here's why. So if I subtract C from both sides, this cancels out, brings the C over there. I now have A is equal to 20 minus C, all right? And so what substitution means is that I now have a value for A. Take this value for A and substitute it into our second equation wherever you see A. A is no longer A anymore. A now becomes this quantity 20 minus C. So you see how we take the A away and now we're inputting C. Well, if C is going to be the only variable in this equation, and that's what we need to solve for, that's what makes it work out. A lot of people will do the opposite. So let me just erase this real quick. A lot of people will say, oh, I got to find out what C is. So if I'm doing substitution, let's get rid of the A and I'll get C is equal to 20 minus A. Well, what happens when I substitute this C? This quantity now goes into wherever C is. And if you notice, the C goes away and now I'm left with A. A is not the one I want. A is the other one, adult. I need children, which is what they're asking me for. So be careful if you're doing substitution and you think, oh, I can solve for C and then put it, and then once you put it in, you're like, wait a second, I thought I was solving for C when it actually changed it to A. So let me go back, get this. So remember, we took away C and that left us with A is equal to 20 minus C, this quantity here. This now goes in here. So it now becomes 15 and then the quantity 20 minus C plus 10C is equal to 225. Okay, so what we did is we took our two equations, we isolated one of the variables, specifically the one they asked us for, children, so C. And when we substitute it back in, that's this quantity going in wherever there's an A, we get this 15 quantity 20 minus C plus 10C. So I'm going to erase this so I can get more room for you. And go. Now let's go ahead and solve this. Remember, distribute. So 15 to our 20 is going to give us 300 minus, and then 15 times negative C is 15C plus 10C equals 225. Okay, so see how all I did was I expanded that out, distributed it, and now all we got to do is solve for C. And you'll notice I've got the 225 on the right side, I got 300. I always tell you, try and get the variables so that they're not negative, but since they're both on one side, let's just leave them there. Unfortunately, we're going to get negatives, but that's okay. I need to subtract the 300. And what's going to happen is I'm going to combine negative 15 and positive 10. So I get negative 5C is equal to negative 75. And so now solving for C, minus 5, divide by 5, negative 5, sorry, it's a negative 5. So it cancels us out. C is equal to, now the negatives will cancel each other out. Remember, these are tickets. Tickets are physical items. You can't end up with a negative number here because you can't have negative tickets. So that's why it's okay. I know they're negative over negative, which gives me the positive. And when I divide them, I get 15. And so C is going to be the correct answer, 15 adult tickets. So depending on if you're comfortable with systems of equations, this is a basic one where they're giving you those single variables at A plus C equals 20, right? And then just know how to substitute it. Okay. Here's another way to do these problems. If you ever get caught up and you just don't know where to go or how to set them up. All right. And we're going to do this kind of more logically. And if you look at these math problems in a logical way, like a riddle or something, a lot of times you'll be able to figure out without having to do so much algebra and all of this. So this is just, it's a little bit of a reach, but if you understand it, then it'll work for you. So they're asking me how many tickets for children. So this column, the answer choices, are representative of children's tickets. Well, then that means there has to be adult tickets. I'm going to make it better because, well, here, let's just do this because remember we have scratch paper. So we're gonna have to rewrite it. So I know that I have children's tickets and they are 5, 9, 15, and 18. Well, then I have adult tickets here. This number is the amount of tickets I have. So if your possible choices are 5, 9, 15, and 18, that means the only possible choices for adult tickets are 20 minus whatever these are. So 20 minus 5, that means 15 tickets. This is going to be 11 tickets. This is going to be 5 tickets. And this is going to be 2 tickets. So now I know that the cost is 15 for adults and 10 for children. So I can do quick math here, right? And we can just say 10, 10. You don't have to put this here, but I'm just doing it just so you can see it. So this is going to be 50, 90, 150, 180. So whatever this number is, this is the dollar amount here. I'm going to have another dollar amount here, and I can just do 15 for these, right? 15 is going to be these. So times 15 times 15 times 15. Remember, you've got a calculator. You don't have to write this times 15 and times 10. You can do it in your head or do it in your calculator. Remember, speed is the name of the game on this test. So when I do 15 times 15, I get 225. Well, now here's the goal. 225 was supposed to be the total for all tickets. So one of these combinations is going to give me 225. That's what I'm focused on right here. Well, if this is 225 alone, there's no way that that's going to work out. Does that make sense? So that's what we're doing. We're combining our children's price and our adult price, and we need to find $225. So let's go to the next one. 11 times 15 is 165. What's 165 and 90 plus 90 equals 255. Well, that's not going to work either because it's too high. The next one, I got 5 times 15, which is 75. What's 75 plus 150? Look at that, 225. And when we did it the other way, it's the same thing. So whether or not you think that's a faster way of doing it, sometimes I do it this way because I feel like it's faster. I've got my chart already. All I got to do is just multiply and add some numbers and it works out. So that's why 15 is the right answer on that one. Again, this is 30. So 180 and 30 is going to be 210. That's not enough. So that doesn't work out either. You're just looking for the winning combination. Okay. All right. Next one. So a little bit of basic geometry, and you'll see this type of question on every math test. They want you to know this as not necessarily, well, I guess it's like general knowledge. Like everybody should know how to do a problem like this. Okay. Whether you believe that or not, a lot of the tests will have a problem like this with basic triangle knowledge. It says, what is the measure of angle B in the figure below? And they only give us 56, and that 56 is associated with angle A. So important notes on this triangle. I've got one angle given. I know that this is the angle I'm looking for, but then I've got these lines here. And what do those lines mean? Those lines are congruent markers. It means that these sides with the one slash on them are the same length. You don't know what length they are. That doesn't matter, just as long as you know that they are the same length. So what do we call a triangle that has two legs that are the same length? And so this is an isosceles triangle. Okay. So isosceles triangle means that you have two sides the same and two angle pairs that are the same. Base angles is what we call them. The second thing we need to know is that all triangles equal 180 degrees. So if I know that this is an isosceles, same sides, right? Same sides go with same base angles. So that's 56 and that's 56. So all triangles start at 180 and then just subtract whatever you have. So minus 56, minus 56. And you don't even have to write this down. And again, that's something that you need to work on as you study and practice. If you know it's 180 and you know it's 56, just pick up your calculator and use your calculator. Writing down the work takes time, obviously. And so to consolidate as much time as you can, do as much mental math and do as much on the calculator when possible. So I just pick it, I go 180. I know every triangle's got 180. I'll take 56 away from that first angle. I'll take 56 away from that second angle. That leaves me with 68. And that gives me D as the correct answer. Okay. So that's what you're trying to do for this one here. Know your triangles. You got to know your triangles. You got to know isosceles. You got to know scaling, and you got to know how many degrees are in a triangle and how to kind of read and look at a triangle. Okay, some spatial math, and these are good problems also that are on all math tests. Okay, so it says the grid below shows a top view of a three-dimensional structure built using identical cubes. The numbers represent how many cubes are in each column. Which of the following best represents the structure? A lot of people have problems with this problem because they have to visualize some 3D object on paper or on the screen, which is in 2 dimensions. So understanding what this is first, because this is your key. This says our front and our right. So that's why these say front and these say right here. Then these numbers are specific to the amount of cubes that are on or that are stacked on top of each other. So the key that we are looking for is a pattern that has, and I'll just go counterclockwise, 3, 4, 2, 1, 3, 2. So going counterclockwise, I'll start with A. So this one back here, how do I know how far it's stacked up? We'll see how this is 1, 2, 3, and this 3 matches this 3. So I know this back column here has 3. So that's good. Let me do this. So I'm just going to put a check mark here because that works. Then this is stacked up 4, and that's supposed to be 4. So that works. This is 1, 2. So that works. This is 1. So that works. And this is 1, 2. And this is supposed to be 3. So that does not work. See how we did that there? Don't look at the back. This is the very back. This is 1, 2, 3, and it's supposed to be 2. So you see, that's how we're going to go about doing it. And then we'll figure out which one is the correct one. So it all depends on how easy this is for you. Like, can you just look at it and see it, or do you have to knock off each block like we just did? So I know that A is not going to work. So let's go to B. And when we go to B, again, starting from the left, going counterclockwise, this is supposed to be 3. Well, I'm going to count 1, 2, 3, 4. And these two are even with each other. And this is supposed to be 3. So right away, it knocks us out. Okay. And that's good. If we can eliminate it on like the first couple blocks, then we're good to go. We'll go C now. And again, we got 3 here, right? I'll do 1, 2, 3, 4. This is 3. So we're good. This is 4. We're good. 1, 2, good. 1, 2, It's supposed to be 1. Doesn't work out. Gone. Process of elimination says D is the correct answer. And as we go through it, you can see we have 3, 4, right? Here's 3, here's 4, check, check. Here's 2, 1, check, check. Here's 3, and then 2 in the back, check, check. That's our answer. Okay. So these spatial math problems with the cubes, where it's asking you, it's always going to ask you for like the bird's eye view. This is what this is. So try not to get too tricked. Again, it's all a matter of how you see it. Some people see these a lot different and are very confused by them, and other people can just look at it real quick and do it. So, you know, it's a matter of preference, and it's your brain. It's the way that you see these things. All right. A toy company plans to make a model of a train engine using a scale where 1 inch represents 4 feet. If the length of the actual engine is 51 feet, which of these is closest to the length of the model in inches? Okay, so right away, when I see scale and when I see something like an inch, like a unit of measurement represents another unit of measurement, I know that we're dealing with a proportion. So right away, I know I've got to deal with a proportion. Well, something that we've come up with here is called matchy-matchy. So whenever we refer to matchy-matchy, we're dealing with proportions. Matchy-matchy deals with, and that's a sloppy matchy-matchy. Matchy-matchy is dealing with our proportions and our units of measure, or what the object is, or something that you can associate with the different units in this problem. Well, the easiest way to do it is units of measurement. I've got inches and I've got feet. In a proportion problem, they're always going to give you 3 out of the 4 because that's how you have to solve it. So I've got 3 values right here, 1 inch, 4 feet, 51 feet. And so now we just match them up. And I match them up by feet to inches or inches over feet, however you want to do it. It doesn't matter, just as long as you keep them in the same. So my matchee is going to be inches over feet. Proportions are always 2 ratios set equal to each other. And you just start by reading the problem over again. And when you come to each value, you know where to put it. It says using a scale where 1 inch, so inch goes on the top, 1 inch represents 4 feet, feet on the bottom, 4 feet. The next one says if the length of the actual engine is 51 feet, where do feet go? Feet go on the bottom. So I don't care, what they're asking me. I know if it's feet, it's always going to go on the bottom. Which of these is closest to the inches? See how inches, it gives you that the missing value is in inches, which means the missing value I have here, I should put that in, is X inches. It's missing. So now just solve it. Well, how do you solve a proportion? You do the old cross multiply divide. What you're going to do is once you set up your proportion, you're done, pick up your calculator. And so the way that you're going to do this by doing no work on paper is pick up your calculator and always multiply the 2 diagonal values first, the ones that have values, not the one that has the variable. So it's just going to be 51 times 1, which is 51. Then you do divide, and then whatever is left over, right? Whatever is left over is only this last value here. So divide by 4, and I get X is equal to 12.75. And so then I look and I don't see 12.75, I see fractions. So the only one that says 12 is 12, so it doesn't really matter, right? So then I know A is the correct answer, okay? The other way that most people do it is they just go ahead and they'll solve it. So it's 51 times 1 equals 4x, and then 51 equals 4x divided by 4, x equals 12.75. Same thing, but I just like it using your calculator because you'll get your answer and then you just click whatever the correct answer is on the screen and move on. No sense in having all of this written down because it's wasteful. But if you're not comfortable with these problems, then write it down. Keep writing it down until you get to the point where you just remember, okay, set up my proportion, pick up the calculator, get the answer, move on. I'm done in less than a minute. And then all that time that you've saved goes to those harder problems that you're having difficulties with, okay? Another thing with this one, I'm gonna get rid of this because I want to show you. Let's just say in the event they gave us crazier fractions, but we'll just use these instead. If you got 12 and 3/4 and you weren't sure what that was, and there were a number of 12s, like it's 12 and 1/8, 12 and 5/8, all that, just know that you can take any fraction and just divide it. So 3 divided by 4, right, gives you 0.75. You know that this 0.75 matches this 0.75. So that's how you know it's got to be the correct one. This one right here, 1 divided by 3 is going to be 0.3333 forever. Well, that doesn't match up with that. So you'll know that that's incorrect. Okay. So don't let the fractions fool you if you get a decimal answer while you work it out on your own. Okay. I like these problems because it's not necessarily telling you to solve one specific thing. It says, which statement is best supported by the data in the graph? So we look at the graph. It says, Mr. Vincent owns a store that sells auto parts. He budgeted $24,000 for the store's expenses last month. The graph below shows the percentage of the budget he reserved for each type of expense. And you see in that pie chart, everything has a certain percentage. So now we go in and we see these answer choices, and we need to know which one essentially is correct. So we got to work these out. We just got to start at the top and work them out. There's no way to kind of pinpoint which one's going to work by the way it's written. These are, you're going to have to do the work. So it means we just, put our head down, do the work, and then make sure we get the right prompt or the right answer. So F says, Mr. Vincent budgeted $15,500 for labor, utilities, and rent. Well, we need to figure out which one is labor, utilities, and rent. So we do 36 plus 14 plus 13. And we get 36 plus 14 plus 13. That's 63%. And so we've got, remember, 24,000 is what we're budgeting. So, pick up a calculator, it's already in your calculator, do 0.63 times 24,000. And we get 15,120. Is 15,120 the same as 15,500? No. So there we go. That's why with this type of problem, you got to work quick. So we're done with that one. We've eliminated that. We need to find one that works. So on to the next one. And the next one says, more than 50% of Mr. Vincent's budget was reserved for rent and utilities. So here's rent and here's utilities. Well, if I do 13 plus 14, I get 27. And if they're telling me that it's more than 50%, well, 27% is not anywhere near 50%. So that's gone too. That was an easier one, which we like those. So then we just keep moving on, right? And Mr. Vincent budgeted $16,800 for labor, insurance, inventory. Okay. So I'm going to have to calculate that one again, but let me just jump down to the next one just because I want to see if it's something where I can do it pretty quick. Less than 50% of Mr. Vincent's budget was reserved for labor and inventory. So if I just look at labor and inventory, I got in my head, I can do 36 and 22, and I know that it's 58, or 36 and 22, it's 58. Well, 58 is more than 50, so that one's gone. And by process of elimination, H is the correct answer, right? So I didn't have to really figure that out like I did the first one. That's less time on your calculator writing things down. That's how you have to attack these tests, okay? Just to show you so that you can not accuse me of lying. We have labor, insurance, inventory. Labor, insurance, inventory. That's 36 plus 22 plus 12, which gives me 3, 5, 50. No, that's not right. Labor, insurance, 12, and inventory, 22, 36 plus 22 plus 12. That's 70. So 0.7 times 24 is 16,800, which is what we needed to find out in the first place. And therefore we've got it correct. Okay. All right. All right. What are we? Problem 6. That's the halfway mark. Let me just double check. Everybody's okay on comments. YouTube looks good. Anybody on the old FB? Let's see here. Yep. Okay. Doing good. No comments there. All right. If you have any comments or questions, please just go ahead, drop it in the comment section, and I will be more than happy to answer that for you. Okay. Oh, screwed up here. Okay. Problem 6, which expression is equivalent to, and then that. So again, something that everybody's going to see are expressions like these, and you have to know how to break them down. You have to know to simplify them. You need to know how to solve them, or you need to know order of operations. So these are all things that no matter what test you're taking, you're going to come in contact with a problem like this. So first thing we got to do is rewrite it, because we can't do anything while it's on the screen, because you just can't. So we rewrite it, and we'll do 5. And we got 4 plus 3 parentheses x minus 6 parentheses, and then brackets, parentheses. So brackets, parentheses, braces, all these types of things. When the number is next to it, it just means it's multiplication. Doesn't matter how fancy or weird it looks like, or absolute value bars. All those next to a number mean that you're going to multiply. That's the operation. So we always want to work our way out. So we go the innermost first. And you see we have x minus 6. Well, I can't do x minus 6 because x is a variable and 6 is not. So they're not the same. I can't combine them. I got this 3 on the outside. So what I'm going to do is I'm going to distribute this 3 to everything. So I'm going to end up with 3x, and then negative 6 is going to be negative 18. That eliminates my parentheses. And then I'm just going to go ahead and rewrite everything now with these brackets. And you can do, it doesn't matter at this point what you do. You see how I have 4 and negative 18 here. I can combine those if I wanted to, which is fine. Or you can distribute the 5 to everything. That's also fine. So I always want to multiply as less times as possible. So I'm going to combine the 4 and the negative 18. So I'm just going to rewrite it as the 4 and 18, 3x minus, and that's going to end up being 14. Like that. Okay. And here we go here. And then finally, go ahead and distribute. That's going to be 5 times 3x, which is 15x. And this is going to be 5 times 14, which is going to be minus 70. And that's it. I can't simplify that any further because it's 15x minus 70. It doesn't say equal something. It just says 15x minus 70. So that's it. That's as far as we can go. And G is the correct answer. Okay. Just following and working your way through it, starting from the middle and working your way out, and then you're good to go. Okay. Okay. Problem 7. So this problem says the dimensions of a rectangular poster board are shown below. Which rectangle can be dilated to fit the exact dimensions of this poster board? So here's a math term that you may see. It's called dilated. And a dilation is a transformation. It means you're transforming this, one of these rectangles, into this poster board here. Like this goes to here, and it goes to here by stretching it out, right? It's like when you take your mouse and you click on the corner and you drag it out and all the sides go out at the same time, they go out proportionally. So that's what it means when you dilate it. It means forever wide it is will go out however long it is, okay, evenly the whole time. So how do I figure this out? Well, they give you these dimensions. I've got 22 and I've got 28. And you'll see all of the dimensions here match up left and bottom. So if you wanted to, you would do matchy-matchy, right? I want to do left side over bottom. And so how does that work, right? So let's start with A. And we always are going off this big poster board. So it's always going to be 22 over 28 is equal to 6 over 7. And that's all you're doing. You're saying, are these proportional? And they have to be proportional because as you dilate them out or stretch them out, gosh, I can't make that 6. As you stretch them out, will they be equal to each other? Are they Are they proportional to each other? So then how do we do this? You cross multiply and divide. And when you do that, you end up getting 154 over 168, right? I did 22 times 7, 22 times 7 equals, and then 28 times 6. So 154 over 168. If they were proportional, then these numbers would be the same. So this one is out. So the next one, 22 over 28 equals 7 over 9.5. So then do 22 times 9.5, and you get 209. And then 28 times 7 is going to give you 196. Well, that doesn't work because the top number is bigger than the bottom number, and they're not even equal, so that doesn't work. The next one, 22 over 28 is equal to 7 over 13. And again, cross multiply. 22 and 13 gives us 286 over 196. And that's not going to work because obviously big number over small number. So by process of elimination, this one better work. So 22 over 28 is the same as 5.5 over 7. And when we do that, 22 times 7 is 154. And 28 times 5.5 is 154. That equals each other, right? 154 over 154 are the same. So D is the correct answer. What you've done is you've just done the proportion. If you stretched out D, if you stretch it out proportionally, however many wide as there is width, or sorry, length, then you will eventually get to this exact dimension here of 22 inches by 28 inches. Okay, so it's all about setting up that proportion. Okay, looks like they want me to go over number 6 again. What was number 6? Okay, number 6, real quick. Somebody just asked to go over number 6 again. So again, remember, we set it up, okay? Innermost first, that means this parentheses. I can't do x minus 6, so let's go outside. This is where the 3 is. So rewriting everything again, I'll do the 5, I'll do the 4, but now it's going to be plus 3 times x, which is 3x, and then 3 times negative 6, which is negative 18. The parentheses go away, okay? And then here, I'll do it the other way because what I did is I combine them. Now you can go ahead and distribute the 5 to everything. So let's do 5 times 4, which is 20. Let's do 5 times 3x, which is 15x. And let's do 5 times negative 18, which is negative 90. Now, the last thing you have to do is go ahead and combine like terms. 15x stays by itself, and we can look at the answer choices and we see they're all 15x anyway. So I know we're on the right track. So I'll take the 15x here, and then now what's 20 and negative 90? It's going to be negative 70. And then that's how you get G for your answer. So Linda, that's number 6 there real quick. Just make sure you're distributing correctly, combining the correct terms correctly, and so on. Okay. So that was number 7. We did proportions, make sure they're all equal to each other. And that's the right one. Problem 8, I've got triangle LPT is an obtuse scaling triangle. If angle P is the obtuse angle in triangle LPT, which of the following is not a valid conclusion? Okay, so again, back to triangles. And now we've got this right here. What is obtuse scaling triangle? Well, let's start with a scaling. A scaling triangle is just a triangle. I never draw them correctly. A scaling triangle is a triangle. Every time it looks the same. It's a triangle that has 3 different sides. So we'll do short side, medium side, long side still looks like it always looks like an isosceles. So, oh my gosh. We'll just call it that, okay? It's a triangle where all three sides are completely different. Maybe if I draw it bigger. Okay, I got all three sides are different sides. It's LPT. I'll do L, P, and T. A scaling is all three sides different. Obtuse means greater than 90. So greater than 90 degrees. Well, if it says P is the obtuse angle, so here's P is 90 plus. Don't worry about how it looks because I know L looks like the bigger one, but just understand that it doesn't matter. Just draw some random triangle, put LPT, and then I've got 90 plus. Remember, it can't be 90 or else it'd be a right angle. It's an obtuse scaling, which means one of the angles, in this case, angle P, is more than 90, okay? So then how does this work out? Let's take the triangle as 180 degrees. If the entire triangle is 180 degrees and I have one angle that is more than 90, that means between these two triangles right here, they must equal, let's do this. Let's do less than 90, right? Because they cannot be equal to 90. So equals less than, that doesn't make sense. Let's just do this, less than 90. So that's what I'm trying to get at here. So we start with A. A says angle L and angle T. So when I add L and T, so here's L, here's T, it is going to be less than angle P. And again, read the question, which of the following is not a valid conclusion? So if I took L and T, here's L and here's T, would they be less than angle P? And yes, they would, because P is greater than 90. These two are less than 90. So that works. But remember, this is a not. That's why this problem is so confusing. And you got to be, you got to be careful because there are problems like this where they throw that not in there. So we're looking for the one that is, okay, which following is not a valid conclusion. So L and T less than 90. Yeah. Make sure I got this right. Okay, so we've got L and T is less than 90. Oh shoot, did I screw up here? Okay, hang on. Which of the following is not a valid conclusion? Not. So L and T is a valid conclusion. We can't do that. How about B? So let me clear this for us. Okay, B says angle P plus angle T. So here's P and angle T is less than 90. Well, that can't be true, right? Because angle P by itself is more than 90. So when I'm looking for which is not a valid conclusion, this right here cannot work because angle P is greater than 90 just by itself. So it throws that whole statement off. So that is the answer. Okay, let's go through the other ones just so we can confirm. C says angle L plus T. So L and T are less than 90 degrees. Well, I've got L and T right here, and I know that they're less than 90 because angle P is the obtuse and it's more than 90, and you can't have them be more than 180 degrees total, right? If I did 91 and 91, right, that'd be 1 degree over each one. I have 182, and that doesn't work out. So that doesn't work out. Okay. L and T. I'm sorry. Yeah, L and T is less than 90. That's right. Sorry. Again, even as I look at this, it gets so confusing. So you can see where the trouble can pop up. All right. And then finally, if you look at D says L, P, and T all equal 180 degrees. And of course, that should make sense because these are all the angles of the triangle. I don't need to know what any of them are in this case, because I know that all three angles in a triangle are equal to 180 degrees. That is a valid conclusion. And so it doesn't work out for this problem. So B is correct because it is the only one that is actually incorrect, if that makes sense, because this is a not problem. Okay. So be careful with problems like this, because yes, they are very confusing, especially dealing with triangles and angles where they don't give you exact measurements. So it's all the stuff that you need to know. Okay. All right. Question 9. Sabrina has a bag of 5 marbles that are identical in size. The bag contains 4 blue marbles and 1 red marble. If Sabrina randomly draws a marble from the bag, replaces it, and then draws another marble, what is the probability that she will first draw a blue marble and then a red marble? So we've got a scenario here with probability. We've got 5 marbles in a bag, 4 blue, 1 red. The important part here is we draw from the bag, but then we replace it. So that's key. All right. So based off of this scenario, we want to draw blue, then red. So what we have to do is, how many blue marbles are there? There are 4 blue marbles out of how many possible? Since there are 5 total in the bag, our denominator is 5. When we make consecutive choices, whether it's picking from a bag, drawing a card, rolling die, all these types of things, we are multiplying. So we multiply the next choice. Well, remember, we are putting that marble back. So 4 out of 5 is if we draw a blue marble. Then we put whatever we pulled back, and then we draw again. So our denominator still stays at 5. And we need a red marble. Since there's only 1 in the bag, it's a 1 out of 5 chance. We multiply this out and we end up getting 4 out of 25. We always check to see if we can simplify it, but then look at the answer choices. The only one that's got 25 as a denominator, 4 out of 25. We can't reduce it. That was pretty easy because it was right there, but sometimes it's all in the narrative in that first problem where that can trip you up. So be careful of that, okay? If this were something different, and I'm just going to do it because they would have it on a test, instead of replacing it, let's not replace it. So I've got a 4 out of 5 chance, but because I don't replace it, I keep the marble out of the bag. This 5, possible of 5, now goes down to possible of 4. So that's what happens when it says don't replace. This still stays as 1 though, because it's only 1, but it's now 1 out of 4 instead of 1 out of 5. Again, we would do 4 out of 20, which reduces down to 1/5. And you would see that they've got the right answer there as 1/5 if you were to do it that way, where you did not replace it. So just be careful, make sure you're reading these questions correctly, because one little term here and there can totally change up the entire problem. Okay, so I just want you to be aware of how that would work out. And then finally, it says the length of a rectangular garden is 20 feet longer than the width. Which equation best describes the garden's perimeter, P? And then they give us these equations. Well, first we need to know, what is perimeter? Perimeter is when we add all sides. If we have a rectangular garden and we're doing this all in our head, you're doing this out. Listen, draw a picture. Always draw a picture. Drawing a picture. Okay. And it says length and width. So let's make this width. Let's make this length. It says the length of the rectangular garden is 20 feet longer than width. Well, if I have width as W and I've got length as L, I know that kind of looks like an H. I've got length as L. I did it again. Then, because 20 more than is, I take my W, I'll do 20 plus W, right? Length is equal to 20 more than width, so that's 20W. So I'll get rid of that L here. Because it's a rectangle, I know that opposite sides are the same. So this is 20 plus W, and then this is W. So how do I find perimeter? Well, just add all sides. Let's do the W's first. I've got 1, 2, 3, 4 W's. So I've got 4W, and then a 20 and a 20 plus 40. So my perimeter is 4W plus 40. Which one of these statements says 4W plus 40? So let me get rid of this because we figured out our perimeter. So I've got W plus 20 plus W. Well, that's just 2 W's and a 20. Well, that doesn't match my 4W40. Let's do this over here. Let me put it up just so we can see. 4W plus 40. So that's out. This is, now I know it's backwards, but the W. So let's distribute the W. What's W times W? W times W is W squared. I don't have a W squared in here, so I don't even have to finish this. That's out. I got this one here, 2W times W. Well, a W and a W again, right? That's 2W squared. Don't need that because I don't have a squared number or square value. Well, that's the only one that's left is J. So I know it's the correct answer. As I do it, I'll distribute this. So that's 2W, and then 2 times 20 is plus 40, and then plus 2W. Combine my 2 W's, 4W plus 40, and that is correct because it matches what we had. Okay. So this is just, they're giving it to you in a different form, a different presentation or representation. And so just knowing how to manipulate these around so that we can match it up and find the correct answer, and you'll be good to go. Okay. All right. That's it. Time flies when you're having fun, right? Last slide is always the answer key. Very important sometimes. And if you have any questions, if I missed something, if you have a request, if you want me to do certain problems, then go ahead and hit us up, info@Kathleen with a K, Jasper.com. Website, Twitter, Facebook, all the major socials were on there. Let me double check here. Okay, I don't understand why you put the width 4 times in the algebraic expression. Okay, let's go back real quick because she does not understand. And yes, you'll be able to watch this again. Once I'm finished with this live session, it's gonna upload as a recording, and then you can skip through and watch whatever problem you need, match it up to whatever you need there. So that was for Chauncey. Okay, for Raven, she specifically wanted to know where I got the 4W from. So let's go ahead and make some room. I'm going to draw that perimeter or that rectangle for you again. Here's our rectangle just like this. Okay, I have width and I have length. And so hopefully you understand when it says 20 feet longer than width. Well, here's width. Well, that means if I add 20 to the width, I'll get the length. So if I do W plus 20, that gives me what length is. Length equals W plus 20. Well, if length equals W plus 20, then let's do this. Let me just do, it's just W plus 20. So if it's the top W plus 20, the bottom is W plus 20. If the left is W, that means the right is W. Okay. So then all I have to do is combine like terms. how many W's do you see? I've got one here, right? This is just W plus 20. They're not connected. I can separate them because they're not, it's not like 20 times W or 20 divided by 2. It's just W plus 20. I have one here, I have 2 here, 3 here, and 4 here. Okay. So now I have 4 W's, right? Because if I do W plus, that equals W plus W plus W plus W, right? That's why I did 4 times W, right? 4 times W is W, W, W. That's what all that is. And then the only thing that's left are my 20s. I've got 20 here and 20 here. What happens when you put 2 20s together? You get 40. That's the perimeter of this problem. And then all you're doing in the answer choices is just working them out until you get this answer here. So I hope that helps. I hope that answers your question. Okay. Any other questions before I sign off? Let's double check. Okay, looking good. Okay, again, so if you have any questions, we're at info@kathleenjasper.com. We, just go ahead and email it. It will get to me. All the math questions get forwarded to me wherever they come from. So if you have anything you have issues with, send a screenshot of the problem, type the problem out, give me an idea of what type of problem you saw or you think you saw or you think you've seen, and I can kind of make it up with that information as well. So I'm here to help you guys out. So whatever you need, let me know. It's all about you guys for this hour every Tuesday. Okay. So with that being said, I'm glad that you can join me. Thank you so much for watching, and I hope that we help you out on these Tuesday sessions. If you need more help, there are over a couple years worth of recordings. You can go on the YouTube channel and you can go back and you can get all of the live sessions that we've done. So with that being said, I hope everybody's enjoying themselves in school. Finals are coming up in like a month or so. We're almost there to summer. Let's get it going, get your tests scheduled so you can pass them, so you can take it easy over the summer and you won't be riddled with a deadline. So with that being said, hope everybody has a fantastic week. And is it Easter this weekend? Yeah, it's Easter this weekend. Have a great Easter. I will see you next Tuesday.